Hello everyone, today's lesson is on ratio tables. This is following the Big Ideas Math Green textbook, Chapter 5, Section 2. So what is a ratio table? We've been studying ratios and how to solve ratio problems. We've already gone over tape diagrams. A ratio table is another organization strategy that essentially is just listing equivalent ratios. You can have vertical ratio tables and horizontal ratio tables. They are the same thing, they're just solved a little bit differently depending on the direction they go in. So this example here, I have all the ratios filled in, and what we would notice is that from this first ratio to the next ratio, we can do this as a times 2, and then we just follow that ultimate rule of math of what we do to one, we do to the other. We see that same just going sideways instead of up and down, or horizontally instead of vertically. One big thing that we need to notice about ratio tables, though, is that it's not an in-out table. It doesn't have the same rule. This next problem is not guaranteed another times 2, and I see many students who like to think that it's just the same thing each time. You really have to really stop and think about, okay, how do we go from 6 to 30? Oh, that's actually times 5, and 4 times 5 is also 20. That's why we know this works. Now, you don't have to go from one to the next. Sometimes you might backtrack, and we could even do from 3 all the way to 30. And if that was the way we want to go, how do we do that? Oh, that's times 10. And 2 times 10 is also 20. So a couple things about ratio tables is they're equivalent ratios that we're making. You want to try to use multiplication or division. You can add or subtract, but you have to add or subtract the ratio. You can't like add 3 and then add 3 to both sides. So just good rule of thumb is trying to always stick with multiplying or dividing these ratios. Alright, so we're going to go ahead and solve some ratio tables. So for this particular example, we are comparing boys to girls. And the way that we fill in these ratio tables is you are always going to start with a complete ratio. That's the only way to do this. So in this particular table, the only place we can start from, at least initially, is at this 5 to 4. We can't start in a place where we don't know. So what you often want to do is you want to try to connect from this complete ratio to an incomplete. So I can go from 4 to 12, and I know that if I want to go from 4 girls to 12 girls, I will have to do times 3. And then we follow that ultimate rule of math where what we do to one, we do to the other. So I'm going to draw an arrow starting and stopping in the same columns, and I would have to do 5 times 3, which tells me that this gap here is 15, or this missing number here is 15. Now to find the next ratio, so this is kind of our next missing value right here, we would really have to think about, okay, how can I get to 40? Because if I can get to 40, I can find out this other number. Well, looking at from 15 to 40, I know I can't do that. I can't multiply 15 by a whole number and get 40, so I'm actually going to backtrack and I'm going to go look at the 5 again, because I know I can go from 5 to 40. And this time, instead of multiplying by 3, I'm actually going to multiply by 8, because 5 times 8 makes 40. 5 times 8 makes 40. I'm going to start underneath the 5 at 4. I'm going to draw that arrow, again, same column here to the same ending column. And then 4 times 8, because what I do to one I do the other, is 32. I now have my 2 missing numbers. The first one was 15. The second one was 32. For this next example, we're going to look at a vertical ratio table instead of a horizontal one. Still solve it the same way. We are comparing cats to dogs this time, and our only complete ratio is 20 to 30, which is not a simplified ratio. And so we are going to have to use division in this problem. So I would probably first connect 20 and 4. And one thing you really need to think about is, okay, if we're starting at 20 and then going to 4, we're going to need to divide because we are going to a smaller number. So oftentimes we're able to get away with just using division. In this case, we will have to divide. I know that 20 divided by 5 gives me 4. So what I do to one side, I'm going to do to the other. 30 divided by 5 makes 6. Now to fill in my last missing number, you could either, since I'm trying to get to 12 here, I can either use 6 or 30. In this case, I'm going to use 6 because I know I can do 6 times 2 to make 12. And doing that on the other side, 4 times 2 makes 8. I now have my 2 missing numbers. In this next example, we are going to take a word problem and we're going to use a ratio table to kind of organize our information. Not necessarily how you'd have to solve this problem, but it's just one way that you could go about it. So our problem is you get paid $25 for working 2 hours. How much do you get paid for working 8 hours? So to start us off, we are comparing money with hours. Okay, and I know that because $25 for working 2 hours. So I'm going to put in that first piece of information, $25 for 2 hours. So I essentially have created my first ratio. I'm also creating a ratio table. It's not a perfect, wonderful rectangular ratio table, but this is typically how I draw them out. So for the next piece of information, how much do you get paid for working 8 hours? So I'm going to go to my hours row, and I would put in an 8 here. Now I just kind of have everything organized, and I want to solve. I know that if I want to go from 2 hours to 8 hours, I would have to multiply that times 4. So coming up here, times 4, 25 times 4 is 100. How much do you get paid for working 8 hours? My final answer would be $100. So one helpful benefit about a ratio table is actually that it can be easily adapted for as much or as little information as you're given. So in this next problem, it's not so much a word problem, but essentially we are told that the ratio, and I can say that because it's in ratio form here, the ratio of A to B is 2 to 3, and we know that A plus B equals 30. So how does a ratio table help us organize this one? So I would probably start off, and we're comparing A and B. So let's make a row for A and B. And my go-to is horizontal tables. If you want to do this vertically, you absolutely can. So we know that the ratio of A to B is 2 to 3. Now, this extra piece of information of A plus B equals 30 doesn't fit into the A or B rows because we just have A's or we just have B's. So what I'm actually going to do is I'm going to add an A plus B row. And I'm able to do that in a ratio table because you can add as much or as little as you need to. Now, next we have to kind of figure out where each piece of information goes. So if I add this A plus B row, we need to add the A's and the B's that we already have. So if I do 2 plus 3, that's going to equal 5. But what do we want it to equal? Well, we want it to equal 30. Okay, well, how do I get from 5 to 30? Oh, I can just do that times 6. And what we do to one, we do to the others. So 3 times 6 would make this one 18, and 2 times 6 would make this one 12. As a double check, what's 12 plus 18? Hey, it's 30. Okay, so it's just an organization piece, is all that ratio table's trying to do. And again, we added this extra row down here. Sometimes you might need to add multiple rows to solve problems out as well. Let's do one more and see if you can do it as well. Alright, so in this particular problem, we know that the ratio of A to B is 4 to 7, and that A plus B equals 44. So I want you to pause this video now and try to solve it by yourself. Alright, so if I was solving this problem, I would start off comparing A to B, and again, if this is a word problem, A and B could be anything. And I know that the ratio of A to B is 4 to 7, and then for this kind of next information, we are adding A plus B. So I'm going to go ahead and do A plus B and add another row. That would mean that 4 plus 7 would give us 11, but I don't want 11. I want to get to 44. How am I going to do that? I would just do times 4. 7 times 4 is 28, and 4 times 4 is 16. So I found those two next missing pieces. How'd you do?